Hello students, welcome to Sri Jendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit electromagnetic waves. So let's begin with today's class. In today's class we are going to discuss about the EM waves. Now what EM waves is, let's have a look. We can say a changing electric field produces a changing magnetic field and vice versa is true, which gives rise to a transverse wave, that is what we call as the electromagnetic waves. So you can see this in the diagram, that let's suppose this is the x-axis, this is the y-axis, and this is the z-axis. There are two components. One of the component is of electric field, another component it is of magnetic field, and that both components are perpendicular to each other. While one more very important thing is that direction of propagation is in the third dimensions. So it is basically if one of the component is in x direction, another component is in y direction, then the direction of propagation is in the z direction. So what we can understood is E cross B is along the z axis, and when this E cross B is along the z axis, we can have this, that electric field component is in the x direction. And as we understand and as we have discussed in the waves, that sinusoidal wave could be represented as it's an E naught sine kz minus of omega t I cap. Same way, if I want to write down the component of B, that would be equals to byj, that is equals to b naught sine kz minus of omega t into j. So this is the time varying electric and magnetic fields are mutually perpendicular to each other, and this are also perpendicular to the direction of propagation of this wave. Please keep this in your mind, that both the components, I mean a component of electric field and component of magnetic field, they are mutually perpendicular to each other, as well as this is their direction of propagation is perpendicular to the third one, and the propagation of direction is perpendicular to both E and B, and that can be given by the right hand rule too. Yes, use your right hand and you can have the direction of propagation. Also you can have the direction of propagation by E cross B. Simply make a cross product of these two vectors of E and vectors of B, and you will find the direction of propagation of wave. The electric vector is responsible for the optical effects of an EM wave, and it is also known as the light vector. So this was the initial detail about the EM waves. Let's discuss the properties, very important properties of electromagnetic waves. First, let me discuss a speed in free space, I mean in an air or in a vacuum. Its speed is equals to c is equals to 1 upon under root of mu naught epsilon naught, and that could be also given as E naught by B naught, which is equals to 3 into 10 to the power 8 meter per second. When I say it's a 1 upon under root of mu naught into epsilon naught, then mu naught is the absolute permeability, and epsilon naught it's an absolute permittivity, and E naught and B naught are the amplitudes of electric field and magnetic field vectors. If EM waves travels in any other medium other than the air or vacuum, the C will be equals to 1 upon under root of mu into E. I hope this is clear. Is it clear? Is it? Great. Now let's discuss the generation of EM waves. What we can understood is, how do we generate it? Is an EM wave can be generated by using an alternating voltage source connected to the two wires, and these two wires will act as an antenna. This is how the antenna should look alike, that this is the alternating current source, and it is a source of an alternating current. That means sinusoidal voltages or sinusoidal current could be connected with the antenna, Antenna is simply a structure with that it has been formed with the help of two conducting wires, and if it has been connected with two conducting wires, it can radiate. It can ideally radiate in a free space. So as the voltage of the AC source oscillates, the electric potential of the two wires will also oscillate. You can see this has become positive and this has become the negative. So the electric charges are also flowing into and of the wires as the voltage of antennas. So as you can see this that if this has been connected, so that it starts oscillating. So from this is, if I consider this as a 0, then this would be the time t by 4, because it's a 1/4 of a complete cycle. And if you want to look the complete cycle, it is something like this. Yes, this is a complete cycle that can be radiated from the or with the help of an antenna. So the electric field continues to oscillate in size and direction, and the wave will propagate away from the antenna, and the charges are accelerated. So the charge undergo SHM, it's a simple harmonic motion with a given frequency, which is also the frequency of the AC voltage source and the frequency of the wave. And a simple LC oscillator and energy source can produce the wave of the desired frequency. So the frequency of oscillating discharge in LC circuit, or we can say frequency of EM waves, that would be equals to 1 upon 2 pi under root LC. This is something like this. It's a 1 upon 2 pi under root of LC. This term is not new to us. We have learned this in alternating current, that this is the frequency which can, or which is having a capability to develop the resonance. I hope you remember it. Yes. Now let's discuss the nature of EM waves. The EM waves are transverse. EM waves are transverse in nature, and they do not require any material medium for their propagation. So if they have been provided medium, they can use it and they will travel it. If they have been not provided any material, they don't even require it. It is something like that. And one very important term, it's a pointing vector S, which is equals to E cross H, or this is equals to E cross B by mu naught, represents the direction of energy flow per unit area per second along the direction of wave propagation. And the unit of pointing vector, it's a watt per meter square. It is same as the intensity. The medium that will offer the opposition to the propagation of waves, and such a hindrance is what we call as the wave impedance. And its value in a medium can be given as Z, that is equals to E by H, or that can be written as under root of mu by E, or that could be written as under root of mu r by ER into mu naught by E naught, where mu r is considered as it is the relative permeability, and epsilon naught r is the relative permittivity of the medium. Is it clear? Is it any doubts up till now? Is there anything? Any doubts? No? Great. So are you ready for certain quick questions? Let's have a look. The question says that the speed of the EM waves traveling through vacuum is, yes, it's a 3 into 10 to the power 8 meter per seconds. It's a speed of light, yes. So correct answer should be both A and B. Next, the medium offers opposition to the propagation of waves. Such a hindrance is called as, yes, it's a wave intensity. No. Electromagnetic waves. No, it's a wave impedance. Yes, absolutely correct. Next, the energy crossing per unit area per unit time is blank to the direction of propagation of EM wave, and that is what we call as the intensity. Yes, so the energy crossing per unit area per unit time is perpendicular. It should be a perpendicular to the direction of propagation of EM wave, and that is what we call as the intensity. Is it clear up till now, or any doubts? Is there anything? Is there anything? No? Let's look at this question. The question says that it is that the oscillating magnetic field in a plane electromagnetic wave is given as By, that is equals to 8 into 10 to the power minus of 6 sine 5000 pi x minus of 3 into 10 to the power 11 pi into t. Tesla. Calculate first frequency, second wavelength, third speed of the wave, fourth electric field amplitude, and next write down expression for oscillating electric field. So please note down this relation and please note down this data and starts doing it. Have you noted it? Did you noted it? Have you? So can we begin with this? So let's look at this, that what they have provided is the By is given, and that By would be equals to 8 into 10 to the power minus of 6 a sine, this is equals to 5000 pi into x minus of 3 into 10 to the power 11 pi into t. So if I write down the standard relation, this is equals to B naught sine k into x minus of omega into t, where I can write that k is equals to this, k is equals to this is equals to 5000 pi, and this k could be written as 2 pi by lambda, as we know. So this is equals to 5000 pi, this pi has gone, and this lambda is equals to 2 divided by 5000 meter. So I got the lambda. Now let's look at this omega, which is equals to 3 into 10 to the power 11 pi, and that could be written as 2 pi by t. This is equals to 3 into 10 to the power 11 into pi. So this pi and this pi has gone, and this t, that is equals to 3 into 10 to the power 11, sorry, I made a mistake, this is t, that is equals to 2 divided by 3 into 10 to the power 11 seconds. So this is the time period, and if I have been asked the frequency, this is equals to 3 into 10 to the power 11 divided by 2 hertz. So this is the frequency. I got the frequency, I got the wavelength. Now next, it's the speed of the wave. So to have the speed of the wave, I must remember the relation which is equals to V, which is equals to omega by k. So this is equals to 3 into 10 to the power 11 pi divided by 5000 pi. So this has gone, and this will give me a 6 into 10 to the power 7 meter per second. So this is the speed of the wave. Next I want the electric field amplitude. It's an E naught. How will I have it? I have the relation which is equals to V, which is equals to E naught by B naught. So it means E naught, this is equals to V, which is a wave velocity multiplied by magnetic field vector. So this is equals to 6 into 10 to the power 7 multiplied by B naught, that is equals to 8 into 10 to the power minus of 6. So this tends to, it's a 480 volt per meter. This is the V, which is equals to E naught in divided by B naught. And last but not the least, it's a electric field expression. So what we understood is that to write down the E, I require this, it's a E naught sine kx minus of omega into t, as well as I want the direction, as we know that wave travels in positive x direction. So E cross B should be along the x-axis. So it's a minus of k cross j, that is equals to plus I. So what I can write, it's an Ez, which is equals to 480 sine, this is 5000 pi into x minus of 3 into 10 to the power 11 pi t volt per meter. Yes, that's it, and this is it. I hope this is clear. Is it clear? Are you sure? So now, do you have any doubts in this? Is there anything? Is there anything? No? Yes. Do you want one more question for practice? Do you? Let's write it down. The magnetic field in plane electromagnetic wave is given as, this is by, which is equals to 4 into 10 to the power minus of 6 sine, it's a 0.2 into 10 to the power 4x plus 0.6 into 10 to the power 12 t Tesla. Find out first wave number, second angular frequency, next wavelength, next frequency, next time period, next wave velocity, yes, and next direction of propagation of magnetic field component. Yes, I want all this. So start doing it quickly. What you need to do is that first just write down the relation. It's a by, which is equals to 4 into 10 to the power minus of 6, which is sine 0.2 multiplied by 10 to the power 4x plus 0.6 into 10 to the power 12 t. So I need to relate this with this. It's a b naught sine k into x plus omega into t. Yes, so this k, that is equals to zero point 0.2 into 10 to the power 4. This is the wave number. Next, it's a wavelength, which is equals to k is equals to 2 pi by lambda. This is zero point 0.2 into 10 to the power 4. So it's lambda, which is equals to 0.2 into 10 to the power 4 divided by 2 pi. Next, I want the omega. So that is the angular frequency, that is equals to 0.6 into 10 to the power 12, and this omega, that is equals to 2 pi by t. So this is equals to 0.6 into 10 to the power 12. So this t, that is 0.6 into 10 to the power 12 divided by 2 pi. This is the time period. And for the frequency, this is equals to 2 pi divided by 0.6 into 10 to the power 12 hertz. Yes, for the wave velocity you can go with the omega by k, and that is 0.6 into 10 to the power 12 divide by this is equals to 0.2 into 10 to the power 4. Yes, you can solve this later on by the meter per second. And magnetic field travels in as they have been connected with the positive, it's a plus. So magnetic field travels in negative. Here y is written, it's a negative y direction. I hope this is clear. Does it? So can you do this kind of questions? This is very easy question, one thing. Second thing is, this is not new to us. Yes, we have been already familiar with this in the unit that is of waves. Yes, so we have did it previously as well. So we must be capable enough to do this in this time too. I hope this is clear. Is it clear? Is it? Great. Now let's discuss certain properties of EM waves. First, we are going to discuss about the momentum, because when we say that it's a wave, it must travel or it must transfer energy as well as momentum from one place to another. So when I say momentum, we can say electromagnetic wave also carries the momentum. So if a portion of an EM waves of energy u propagates with speed c, then the linear momentum could be given as energy u divided by speed c. And when the incident EM wave is completely absorbed by a surface, it delivers energy u and momentum, that is the u by c, to the surface. But there are other kind of surfaces too. So when a wave of energy u, which is totally reflected from the surface, then the momentum that is delivered to the surface can be given as 2u by c. So if it is completely absorbed by a surface, then it would be a u by c. And when it has been totally reflected from the surface, then it would be a 2u by c. I hope this is clear. Next property would be of radiation pressure. So when I say pressure, it is basically the force by area. And when I say force, it's a delta P by delta T multiplied by area. So when I say radiation pressure, it is the momentum that is imparted per second per unit area on which the light falls. And the radiation pressure is the white tails of the comet points away from the sun. As well as for a perfectly reflecting surface, this pressure would be equals to 2s by c, where s is the pointing vector that we have discussed and c is the speed of light. And for a perfectly absorbing surface, this should be is equals to s by c. So when electromagnetic wave is incident on a surface, and the total energy transferred to the surface in a time t is the u, then the magnitude of the momentum that can be delivered to the surface, that is equals to u by c. Please note this down. This is true for complete absorbing surfaces, and u is the energy transferred and c is the velocity or the speed of the light. So when the sun shines on the hands of a person, he feels the absorption of electromagnetic waves, and that's why our hands get warm. So when the radiation incident on a surface is entirely reflected back along its original path, then the magnitude of the momentum delivered to the surface, that could be given as p, which is equals to 2u by c, where c is the velocity of light. And this is the case when radiation incident on a surface, pressure the pressure exerted on the surface by the electromagnetic wave is equal to the radiation pressure, that is what we call as pr. So this I, intensity, that is equals to, when I say it's an intensity, that is equals to energy divided by area into time. So this energy by area into time, intensity could be given as it's a p by a into t, and this is equals to, because we have the relation, it's a p is equals to u by c. So this is, u is the energy, this is equals to p into c divided by a into t. I hope this is clear. So this is equals to I by c, then it would be a p divided by t into a, and it's a momentum divided by time, which is equals to force. So this is force by area, which is radiation pressure. So radiation pressure in terms of the intensity, could be given as, this is equals to I by c, and this is for pure absorbing surface, and this is for pure reflecting surface. So this PR, which is equals to 2I by C, where total reflection is back along the incident path. I hope this is clear. So have you noted it? Did you noted it? Are you sure? Are you sure? Any doubts in this? Is there anything? No? Great. Let's look at certain quick questions. Electromagnetic waves obey the principle of, yes, they obey the principle of superposition. Next, when electromagnetic wave strikes a surface, a pressure is exerted on the surface, and that pressure is known as the, yes, that is what we call as the radiation pressure. I hope this is clear. Is it clear? Great. Now are you ready for question? Are you? Let's have a look. The question says that an electromagnetic wave, an EM wave of intensity 10 watt per meter square strikes a small mirror of area 20 into 10 to the power minus of 4 meter square, held perpendicular to the approaching wave. What is the radiation force on wave? Have you noted it down? Did you? It says that an EM wave is there and it is having the intensity that is equals to 10 watt per meter square, strikes a small mirror. Now the mirror word has been given for a very purposefully, because when I say mirror it is perfectly reflecting surface. So this is perfectly reflecting surface, and that's why they have used the word it's a mirror. And that area would be equals to 20 into 10 to the power minus of 4 meter square. Yes, what is the radiation force? First what I need to do is I can calculate the pressure, which is equals to the radiation pressure is equals to, it's a 2I by C, and this pressure should be is equals to force by area. So this force could be equals to 2IA by C. So this is what I required. So let's get it done. It's F which stands to 2IA by C. So this is equals to 2 into intensity, and that intensity would be equals to 10 watt per meter square, area which is equals to 20 into 10 to the power minus of 4 divide by C, it's the speed of light, which is equals to 3 into 10 to the power 8. So this is equals to 2 into 10, which is 20, 20 into 20, which is equals to 400, which is 4 into 10 to the power 2 multiplied by 10 to the power minus of 4 multiplied by 10 to the power of minus of 8 divided by 3. So this is 4 by 3, which tends to 1.33 multiplied by minus 4 minus 8 minus 12 plus 2. This is 10 to the power minus of 10 Newton. I hope this is clear. Is it clear? Is it? What was your answer? Was it same? Was it? Are you sure? Great. Let's change the question little bit and we can get it done. Next question is that if instead of mirror a surface of same size but painted with black color is kept, find out radiation force. Yes, what will be the situation? So this is in continuation with the previous question, that if we have not kept the mirror but we have kept the certain surfaces and that has been painted with the black color, so what would be the radiation force? So now it's a pressure which is equals to force by area, and which was equals to I by C, because it's a surface that has been painted with the black color. So if it has been painted with the black color, that means it must be completely absorbing surface. So this force is equals to IA by C. I hope this is clear. So it is, if I took a ratio of this F completely absorbing divided by F completely reflecting, this is equals to IA by C, this is equals to 2IA by C. So this it's a 1:2. So this is FA, which is equals to FR by 2. So this was 1.33 divided by 2 into 10 to the power minus of 10 Newton. I hope this is clear. Is it clear? Is it? Are you sure? Do you have any doubts? Is there anything else? Any doubts? Any doubts? No? Great. Now let's discuss about the energy of an EM waves. So when I say energy of an EM wave, we say that the energy in EM wave is divided equally between two parts, electric fields and the magnetic fields. And the energy density of an electric field could be given as this is equals to 1 by 2 epsilon naught into E square, and the energy density of the magnetic field, this is equals to UB, which is equals to B square by 2 mu naught. And experimentally we have found that the energy density of magnetic field and energy density of electric field will be the same. So if I took a U average, which should be equals to UE plus UB, that is equals to 2 UE or 2 UB, so that could be written as epsilon naught into E square, or it should be equals to B square by mu naught. I hope this is clear. Yes, let's discuss this in somehow little in detail, and we will have some more clarity on the energy. When we talk about the energy of EM waves, we generally focus on to two segments. One of them is the average energy density, and the another is instantaneous energy or instantaneous energy density. Yes, so first let's understood that we have two components of magnetic field, that is equals to B, that is equals to B naught sine kx minus of omega t, and the electric field component will be given as E naught sine kx minus of omega t. If I talk about the instantaneous energy density, then this instantaneous energy density, that could be written as this is equals to half into epsilon naught into E square. So this is 1 by 2 into epsilon naught into E square. This is the electric field. So if I make a square of this, this is E naught square sine square kx minus of omega t. Same way, this UB, this is equals to B square by 2 mu naught. So this is equals to B naught square by 2 into mu naught, sorry, this is equals to sine square kx minus of omega t. I hope this is clear. If I took an addition of this, and if I want the maximum value of this, then this is maximum when this is sine square kx minus omega t is 1, and if this will be the maximum, this is equals to B naught square by 2 mu naught. Same thing is true for this as well. This is UE maximum when this term has become 1, and this is equals to 1 by 2 into epsilon naught into E naught square. Yes, so I got the maximum value of UE, it's an energy density of an electric field. I got the maximum value of the magnetic field energy density. If I took a total, this U total would be equals to UE max plus UP max. So this is the total of the UE max is plus UB max. So this tends to it's a half into epsilon naught into E naught square plus 1 by 2 into B naught square by mu naught. But as we have discussed that practically that has been verified that epsilon naught into E naught square would be equals to B naught square by mu naught. So this is equals to half plus half, that is equals to 1. So this is equals to epsilon naught into E naught square. If I want this total energy in a form of electric field component, or this could be written as B naught square by mu naught. If I want this energy in the magnetic field component. This is u total in terms of, this is u total in terms of the instantaneous energy density. Have you noted it? Please note down this. Have you noted it? Are you sure? Have you noted it? Now, let's discuss about the average energy density. So when I say average energy density, what relation I was having is the UE, it's a half of epsilon naught into E naught square into sine square kx minus of omega t, and this magnetic field component will be equals to half of epsilon, this is half of b naught square by mu naught, that is equals to sine square kx minus of omega t. If I took an average of this, then we have understood and we have derived this, that average of sine square theta, it's a 1 by 2. So this is UE average will be equals to 1 by 2 multiplied by epsilon naught into E naught square into 1 by 2, that is equals to 1 by 4 epsilon naught into E naught square. A same way UB average, that is equals to 1 by 2 into B naught square by mu naught into 1 by 2, that is equals to B naught square by 4 mu naught. This is the UB average. So if I took, it's a U total, and if I take an average of this is equals to 1 by 4 into epsilon naught into E naught square plus 1 by 4 B naught square by mu naught. As we understood that it's an epsilon naught into E naught square, that is equals to B naught square by mu naught. So this is equals to 1 by 4 plus 1 by 4, it's a 1 by 2 to epsilon naught into E naught square, or it could be written as 1 by 2 into P naught square divided by mu naught. This is U total average. Yes, this is the total average density of an electromagnetic wave. So basically I hope now you clear with your idea that why there is a two difference, because if you look at this U total average, it's a 1 by 2, and if you look at this, that U total, but that is the instantaneous energy density, this is not 1 by 2, this is the complete one. I hope this is clear. So there is a little variation between this two, and that's why that has been changed. I hope this is clear. Is it clear? Have you noted it down? If not, please noted it down. Have you noted it? Are you sure? Have you noted it? Did you? Great. So are you ready for one of the question based on this? Are you? Let's have a look at the question. Keep your pen and paper ready, and you are going to calculate it with me. Let's do it. Suppose the question says that in an electromagnetic wave, the amplitude of electric field is 1 volt per meter. Find out first the amplitude of magnetic field. Next, average energy density of electric field and magnetic field. Next, the average energy density of wave. I hope this is clear. Yes? Is it clear up till now? Great. So let's do it. What I have been given is that I have been given only the amplitude of electric field vector. It's an E naught has been given, which is equals to 1 volt per meter. And let's work for the B naught. We understood that this is C, which is equals to E naught by B naught. So from this it's a B naught, which is equals to E naught by C, and it would be 1 divided by 3 into 10 to the power 8, which is equals to 1 by 3, which is 3 by 3, 3.33 into 10 to the power minus of 9 Tesla. Yes, it's a 3.33 into 10 to the power minus of 9 Tesla. Now what I want the average energy density. Yes, it's generally we have denoted it with U, so let's do it. It's an U average, which should be equals to 1 by 4 into epsilon naught into E square. So this is equals to 1 by 4 into 8.85 into 10 to the power of minus of 12 multiplied by 1 square. So when I keep this 1 square, this is equals to 2.2125 multiplied by 10 to the power minus of 12. It's a joule per meter cube. This is average energy density, as well as this is the same. This is for the electric field component, and this is the same for the magnetic field component as well. This is equals to 2.2125 into 10 to the power minus of 12 joule per meter cube, because both the energies are equal. So this is UP and UE. When I find out your U total, this is equals to UB plus UE, and when I say it's a UB plus UE, this is equals to 2 into 2.2125 multiplied by 10 to the power minus of 12. This tends to 4.425 into 10 to the power minus of 12 joule per meter cube. I hope this is clear. Is it? Are you sure? Did you understand this? Did you understand this? Yes? Great. I hope this is clear. So is it clear what energy density is all about and everything about the energy density? Now let's discuss one more very important thing about the intensity. When I say intensity, it is the energy that is crossing per unit area, per unit time, in a perpendicular direction of propagation of EM wave. That is what we call as the intensity. Now let's discuss the intensity for a point source. So intensity of the electromagnetic radiation, intensity of the electromagnetic radiation from an isotropic point source at a distance r could be given as, this is equals to intensity I, which is equals to P divided by 4 pi r square. Yes, this is in reality, this is something like this. It's an energy by area into time. When I say energy by time, this is equals to the power, what I have written, and area, when and when it's a point source, when and when it is a point source, that will, the point source will radiate the energy in every possible direction. And when this point source will radiate the energy in every possible direction, its area, its a surface area would be given as, this is equals to 4 pi r square. So this is The intensity. This is the intensity for a point source. Have you noted it? Have you? Did you get this? Are you sure? So, would you like to have one of the question based on this intensity of the point source? Would you? Let's have a look. Suppose that the question says that calculate the electric and magnetic fields produced by the radiation coming from 100-watt bulb at a distance of 3 meter. Assume that efficiency of bulb is 2.5 percentage and it is a point source. How will you do this? How will you do this? What they want? We want electric and magnetic fields produced by the radiation coming from a 100-watt bulb. So power is given, that is of 100 watt, at a distance, that is the distance from the bulb is given, it is the 3 meter. One more very important term is given, that is that it is having the efficiency of the 2.5 percentage only. It is having the efficiency of 2.5 percentage only. So output power is equals to efficiency times the input power. We understood that efficiency is equals to P output by P input, and they have given the efficiency which is equals to 2.5 percentage only. This is equals to 2.5 into 100 by 100. It's a 2.5 percentage. So it is only 2.5 watt that is useful to us, and other all things is wastage to us. So first let's calculate the intensity, and the intensity could be given as this is equals to power divided by area. This is equals to intensity, and this is equals to 2.5 divided by area, which is equals to 4 pi r square. So this is equals to 2.5 divided by 4 into pi into 9. If I solve this, this is equals to 0.022 watt per meter square. This is the intensity that could be available at a distance of 3 meter from a point source. Now this is the total intensity, within which half of the intensity is provided by electric field components and other half is provided by magnetic field components. So half of this total is provided by the electric field components, and the other half is being provided by the magnetic field components. So let's talk about that, what amount of them is provided by the electric field and what amount of them is provided by the magnetic field. So it's in half of the I, or I should say it's in half of the epsilon naught. into E square RMS into C. So this is equals to 1 by 2 multiplied by, this is what we get, it's a 0.022. So if I want to find out the ERMS, that is equals to root of 0.022 divide by, it's an epsilon naught, which is 8.85 into 10 to the power minus of 12 multiplied by 3 into 10 to the power 8. So this is simply 2.9 volt per meter. This is ERMS. If I want the magnitude, it's an epsilon naught, which is equals to root 2, it's an E naught, sorry, my mistake, it's a E naught. E naught is equals to root 2 times of ERMS. So this is equals to root 2 multiplied by 2.9, which is approximately equals to 4.07 volt per meter. This is E naught. Now let's calculate the BRMS too, and that is equals to BRMS. This BRMS should be equals to ERMS by C. So this is 2.9 divide by 3 into 10 to the power 8. This tends to, it's a 9.6 into 10 to the power minus of 9 Tesla. Or if I want the amplitude of the magnetic field, this B naught could be given as, it's a root 2 times of BRMS. So this is equals to root 2 multiplied by 9.6 into 10 to the power minus of 9, and this is equals to 1.4 into 10 to the power minus of 8 Tesla. I hope this is clear. Is it clear? Is it? Are you done with this? Have you? Great. So now do you understand completely how to calculate the electric field components, how to calculate the magnetic field components and everything? Are you sure? Are you? Great. Now let's discuss a certain theoretical parts, and that is the electromagnetic spectrum. So what is electromagnetic spectrum? We can say that the orderly distribution of EM waves according to the wavelength or the frequency in the form of the distinct groups with different properties is known as the electromagnetic spectrum. As you can see, this is just the visible spectrum. It's a 4 into 10 to the power minus 7 to 7 into 10 to the power minus of 7, but it is not that only. It is not that only. It can be beyond that also, that even gamma rays could be there, even X-rays could be there, even the UV rays, it's what we call as the ultraviolet rays are there. This is just this much of part what we have seen it to you, and that is of visible light. Even beyond that, it's infrared rays are there. There could be a radar rays, there could be an FM, which we what we call as the frequency modulation. It's a TV waves could be there, short waves could be there, amplitude modulated waves could be there. So there is a very large band of different wavelengths and different frequencies are there. So the EM spectrum, there is no strict lower or upper limit for the EM wave frequencies. The range of frequencies assigned to the different types of waves is somewhat arbitrary, and those regions may overlap with each other, and the names of the different regions were chosen based on how the radiation in each frequency interacts with the matter, and on how that could be generated. So we have written some of the uses of the EM spectrum and their uses. So the gamma rays are there, that gives information on nuclear structure, or that can be used in medical treatment. X-rays, that we understand that they are being used for the medical diagnosis and treatment, and they are also being used for the study of crystal structure or industrial radiograph. UV rays are used to preserve the food or sterilizing the surgical instruments or detecting the invisible writings or fingerprints, etc. Visible lights to see the objects. Infrared rays. Infrared rays to treat the muscular strain or for taking photography in fog, etc. They are the infrared rays they are used. So these are the electromagnetic waves contains, starting from the gamma rays, then the X-rays, then the ultraviolet rays, then the visible light, then the infrared rays, then the microwaves, and then at last it is the radio waves. I hope this is clear. Is it? Great. Now let's look at the questions. The orderly distribution of electromagnetic waves according to the wavelength or frequency in the form of the distinct groups having widely different properties is what we call as the electromagnetic spectrum. Next, infrared rays are used in, yes, for the fingerprints, no, for taking photography in fog, yes, for treatment of muscular strain, yes. So this both is clear. So this should be the correct answer. I hope this is clear. So let's wind up the session over here. This was all about the properties and structures and how we use the EM waves. This is all about them. Please go through this very carefully. Yes, this is a very shorter unit, as well as it contains a lot of information, so you need to go through the NCRT book as well for this. Yes, because it contains a lot information. I tried my best to cover as many as possible, but there are chances that I have missed some information too. So please go through this. Please read it and learn it. Thank you. Have a good day. Take care.